Well, good evening, everybody. Welcome to the 939th monthly meeting of the Amateur Telescope Makers of Boston. I think we're going to have a great meeting tonight. We've got got Andrew Chaikin is going to be our guest speaker, space historian, knows pretty much everything that could be known about the Apollo era missions. And so I'm really looking forward to hearing his presentation tonight. So here's a little dose of humor brought to you by the Observing Committee. It's mostly by Glenn Chappell, but I thought that was pretty funny. What's the chance of getting hit? You're twice as likely to be hit by lightning than by getting hit by an asteroid. I think I sent that to Glenn. I thought that was pretty funny.
Yeah, you did.
Yeah.
Thank you.
You're welcome. Can you guys hear me okay?
Yeah, we'll go to the next slide. You guys can hear me okay?
You guys hear me okay? That's the question. Can you hear me? Okay. All right, next slide. Words of wisdom.
Yeah, and this is very appropriate this time of year. Spend your nights getting intoxicated with photons. Now, St. Patrick's Day is less than a week away, and we can't obviously go to the clubhouse and have a wild party, and a lot of the bars are still closed, but you can always get intoxicated with photons. So if St. Patrick's Day or the evening is clear, get out there and do some sky gazing and get yourself intoxicated with photons. You can't get arrested for observing while intoxicated, so that's the important thing there. Next slide. We all set? Okay. The evening sky is kind of devoid as far as naked eye planets, but we have lined up this month. On March 14th is coming Sunday, 2 a.m. Set your clocks spring ahead, and that means we lose that hour of evening darkness. Daylight saving times begins then. On March 19th, about an hour after sunset, Mars is to the right of a waxing crescent moon. Again, I think most of us know where Mars is. It's getting tinier and tinier each week. But you want to keep an eye on Mars with the naked eye because it's going to be kind of neat. I'll skip just a second. On the 20th of March, the first day of spring, the lunar X and lunar Y will be visible as a 4-hour spread centered on about 6:09, 6 o'clock in the evening. So that's something to look forward to. If you've never seen the lunar X and Y, they're very easy to see. Right, the lunar X is kind of near the middle of the Terminator. Then on the 22nd of March, Mars and Aldebaran will be close to each other. They're only a few tenths of a magnitude different in brightness, and it's kind of neat to just compare the colors of these two. Try with the naked eye first, and then with binoculars. They'll be about 7 degrees apart at their closest, but for the most part, the latter half of March, it'll be good to see them together in the evening sky. So give them a look-see again, naked eye, and then with binoculars. On Tuesday and Wednesday, there is a grouping of the planets in the morning sky, especially Jupiter and Saturn, which are separating. This is in your southeast sky in the morning. And on April 6th, about an hour before sunrise, you'll see the waxing crescent moon just below Saturn. And then the following morning, it'll be a little bit below Jupiter. And Rich added this, good to know, is that looking ahead on June 10th, there will be a partial solar eclipse at sunrise. And I guess I'll let Rich take over on that one, because we were talking about that the other day. Go ahead, Rich.
Well, let's see. I don't know why my mouse isn't doing what it's supposed to do. Hold on. So I went on Sky Safari and grabbed the screenshot for the morning of Thursday, June 10th this is at 5:30 a.m. When a very eclipsed sun will rise up in the northeast. It looks like it's really high above the horizon, but that green line is the horizon right here. At the altitude of the moon at 5:30, this is from Provincetown. I was trying to look for sweet spots. It's only about 2 degrees above the horizon. So this is definitely a sunrise eclipse, and if you are so inclined, I would break out those 2017 eclipse glasses and find yourself a nice spot where you've got a clear view to the horizon, preferably along the ocean. And maybe there won't be any fog that morning. Maybe we'll have a pretty nice eclipse to look at. So that's coming up in a couple of months. And I also wanted to add one more thing. I don't think Glenn knows this is here, but ongoing, this is a star chart that allows you to find the asteroid 4 Vesta. It's currently in the hindquarter. It's passing through from the hindquarter of the Leo of the Lion into the body, loop back around when it resumes its prograde motion throughout the springtime. It's about 6th magnitude now. I was looking at it the other night. and it, looks like a star. If you've got a monster telescope and ultra steady skies, you might actually be able to resolve it as a disk. It's big enough to it's about a half an arc second. So it would take some sort of telescope to do that, but you might get lucky. In June, it'll pass relatively nearby the galaxies M66 and M65 here in Leo. So just something that's ongoing throughout the spring. If you have never taken a look at an asteroid, this is the asteroid that has the highest albedo, the highest reflectivity, so it's fairly bright, despite the fact that it's about 135 million miles away from the Earth right now. And this was, if you want to read more about it, this is an article Bob King wrote for Sky and Telescope's website. So just click on that and click on that, and you can read all about it. Perfect. I think that's the last slide for the.
No, we have the Observer's Challenge.
Oh, the Observer's Challenge. That's right.
That's right. Can't forget that.
How could I forget?
The March Observer's Challenge is the galaxy NGC 2685. It's kind of an oddball. It's a lenticular polar ring galaxy. And it's located, if you look at the chart at the upper right there, it's just a little bit below its star called, I think it's Mosquida, or it's Omicron Ursa Majoris. And Rich has the arrow showing that. And the arrow, if you look, it passes through, it looks like 3 stars, kind of a hockey stick. And one of those stars is the star 17, Ursa Majoris. And I got to tell you, Rich was saying it was pretty easy for him. He must be a better star hopper than I am. I had a hard time because it's in a barren area. You've got a long haul between Omicron and getting down to 17. It took me a little while, maybe about 10 minutes of star hopping before I centered on it. Just below that, as a closer view, there's Omicron in the upper right there and 17 below. And it's midway between, and it's bracketed by a pair of 6th magnitude stars. You see 2685. And then the close-up view, right over in the right there, that shows it between those 2 stars. And I checked it out a couple of nights ago, and it was right where that X is. I plot these things using the AAVSO's variable star plot. I plugged in the coordinates and printed up a chart. This is a limiting of 11th magnitude, and that galaxy was right where it shows it there. I made a sketch, and we'll see that it's in the next slide.
Before we click over, Glenn, let me just tell you how I got there. So here's Omicron at the tip of the bear's nose. This little line of stars right here is where I went from here to here. This is a nice double star right here that it kind of makes this a little bit easy to pick out. And then from there, I was able to find these 2 6th magnitude stars. So I went that way from here to here to here. And you're right, it's exactly where you show it to be. And here's your sketch right there.
Okay, this was with a 10-inch scope. And I got to tell you, this thing was small. I wasn't even sure I'd seen it at first. It was just a little smudge. But I made a sketch, and it seemed to me that it was extended a little bit north, kind of a north-southish sort of. So I just made the sketch, and I drew it the way I saw it with my averted vision. And then I went inside and I looked on Wiki, and I found, or on the internet, and I found a picture, which is over on the right there, of the galaxy in about the same field of view. And you can see there's a star just to the right of the galaxy. And I think what I saw is obviously just the nuclear part. And this is one of the things about sizes of galaxies. This galaxy is an 11th magnitude galaxy, and it gives size of 4.6 by 2.5 arc minutes. But I doubt what I saw was that big. I think I was looking at the nucleus, and you can see in the photograph, I just saw that bright central area. I didn't see that ring that surrounds the galaxy, that helical, anything there. But this was with a 10-inch scope. So again, any of you that send your observations to Roger Ivester, if you have a bigger telescope, say 18, 20 inches long, 20 inches or so forth, you might want to see if you can see that helical apparition there in the middle of the galaxy. I just wasn't able to see it with a 10-inch. Next slide, we got some pictures.
I looked at, Glenn, before you move on, I looked at the galaxy the other on Sunday night with my 20-inch, and I saw no hint of any kind of structure, but my skies are terrible here, so.
Yeah. What's your magnitude limit?
Well, the snow is melting, so it's getting better, but it won't get much better than 4.8 or 4.9.
Right. See, that's about the same. I got about 5th magnitude here. Used to be 6, but those are a thing in the past. Oh, and I see Bruce Berger saying we should grab that one by all means. Okay, anyway, this is Doug Paul's image, and you can see a little bit of the spiraling there in the middle of it. And then with Mario Mata's larger telescope, the 32-inch, the next slide, And you can see some of that detail there in that picture. And that bright star above is that one I showed you in the sketch I made. This is having a north at the top in this particular orientation. And that's about it for this month's Observing Committee report. As always, keep looking up.
Good, and I'll keep sending out my 19 plus objects lists and my new mini Messier marathon lists for you folks to hopefully my goal is to inspire everyone to get out and do some observing, especially when we've all been so isolated during COVID. So I'll keep sending that stuff out, and as we get closer to the time, Jupiter, and I'll let you know what the Great Red Spot this year. Jupiter is going to be undergoing the satellites are undergoing mutual events as we pass through the plane of their orbit. So those are always fun to watch. And so there's plenty to do with Jupiter as we get into the summertime. So more to come on that. Glenn, thank you very much. I appreciate your effort and your time. I am so excited to welcome Andrew Chaikin to our meeting tonight. Andrew, I've given you co-host privileges, so you'll be able to share your screen in a moment. So let me read to you what is on the screen. So space historian Andrew Chaikin is best known as the author of A Man on the Moon, The Voyages of the Apollo Astronauts, which tells the stories of the Apollo missions through the eyes of the astronauts. The book was the main basis for Tom Hanks's 12-part Emmy-winning miniseries for HBO, From the Earth to the Moon. A graduate in geology from Brown University, Andrew has brought his knowledge of planetary science to his writing and teaching. As a visiting instructor at NASA, he has taught the history of human and robotic space missions, as well as the human behavior aspects of success and failure in space flight projects. I had the pleasure of listening to Andrew speak at the Conjunction, a long time ago. I've been a fan of the Apollo missions from when I was a kid. It's really one of the reasons that many of us got involved in amateur astronomy. So without further ado, I know you're all on mute, but let's give a nice round of applause to Andrew. Andrew, I'm going to stop sharing my screen, and that should give you the chance to go ahead and share your screen.
Okay, cool. So let me do my little magic here with AirDrop, since I'm seeing you via my iPad, and I'm going to get it from there to my laptop from my laptop to there. And I will open this shared ongoing meeting and let me know what you see.
Stories and lessons from the moon.
There you go. All right. Sounds like I'm getting some kind of echo. Jeff needs to mute. You muted, buddy? There you go. All right. Well, thank you all for having me. It's fun to be with you guys. Been a long time since I was a Boston denizen, but I spent a lot of years in Boston and really cut my teeth as a space reporter, journalist. Kelly Beatty taught me almost everything I know, not quite everything. And I say that not just because he pays me to say that, but seriously, it's fun to be able to talk to you guys. So, Rich and I agreed that I would just kind of take you through some of the experiences that I heard about when I interviewed the astronauts, the Apollo astronauts, for my book, A Man on the Moon, which came out in 1994 originally, although it seems to keep having new life. It just came out yesterday, yesterday as a 2-volume illustrated edition from a publisher in the UK called the Folio Society. So I'm always kind of amazed to see the longevity of the book. But let me just kind of get into this by starting with the astronauts as they were when I did finish my book and when it came out. This is a picture that I took at the Experimental Aircraft Association gathering in Oshkosh, Wisconsin, in July of '94 for the 25th anniversary of Apollo 11. And so you see here on the stage, like 15 Apollo astronauts representing almost every mission, well, pretty much every mission. Not all of them were still around and not all of them could attend, but it's a pretty good selection. And you can see Neil Armstrong sort of right of center there, just to the left of Gene Cernan, who's in the pink shirt, the first man and the last man on the moon. It was pretty amazing to be able to hang out with them at this point, having finished my book after interviewing them and spending about 8 years trying to, really work my way up as a writer to the level of writing that I felt the story deserves. So that was kind of my victory lap. But you look at them in this picture, and they don't look like remarkable people. They don't even look like, most of them don't even really look like what you'd imagine an astronaut to look like. Of course, this is, like I say, 25 years later, so they're not the young, trim, jet jockeys that they had been. But still, obviously an extraordinary group of people. Now, most of them, almost every single one of them, the only one who went to the moon was not a professional pilot to start with, was Jack Schmitt, the geologist who was on the last landing. Most of them were test pilots or fighter pilots. And so, here's Neil Armstrong. Before he became an astronaut, he was in fact working for NASA at the high-speed flight station out at what became the Dryden Research Center in California. And there he is posing after flying the rocket plane, the X-15 rocket plane, to the edge of space. And Neil was actually, I would say, one of the more broad-minded guys that came into the astronaut program. And by that, I mean that even though the title of this slide says pilots first, explorers second, and that is certainly true, they were motivated by wanting to, fly higher and faster. But Neil had a sensitivity to exploration and became a really good lunar explorer by the time he went there. So, Neil, it's interesting. People always ask me, what did these guys have in common? And, we all know they were very competitive. They were overachievers and so on, very smart. But what I find more interesting are the differences. And so, that was something that I worked very hard to try and capture in the book, was the differences in personalities. And some guys were just pure cold warriors. Frank Borman didn't give, there was no love lost by Frank Borman for, the geology of the moon. He would not have been a good choice to command one of the science-oriented missions. He just wanted to beat the Russians and score that victory for the country as part of the Cold War. Now, there's a lot that could be said and has been said about what it takes to prepare for a mission to the moon. And these pictures are really just a small sampling of that. So on the left, you see one of the guys, I think it's Pete Conrad, flying a very strange looking vehicle called the Lunar Landing Training Vehicle, which was actually a flying simulator that replicated the performance and the handling characteristics of the lunar module, the lander, in the moon's 1/6 gravity, using a jet engine to support 5/6 of the weight of the vehicle and a set of rocket engines to support the remaining 1/6. And of course, that was computed dynamically as the thing flew. Very unforgiving vehicle, made the managers really nervous, but the astronauts insisted that it was essential to train for landing on the moon when you would only have one shot at pulling it off. In the middle at the top, you see Pete Conrad and Al Bean in the fixed base lunar lander simulator, where they went through every phase of what they would do in the lunar module from the time they powered it up until the time they landed and then lifted off from the moon and rejoined the mothership in lunar orbit. So obviously that was an essential piece. On the right, you see Ed Mitchell and Al Shepard, fully suited, pressurized in their suits in the KC-135 cargo plane that NASA used to give astronauts a taste of not only weightlessness, but also lunar gravity. And I had I've had several flights in the KC-135 in weightlessness as a journalist and as a test subject and so on. But the very last time I flew, which was in '99, I got a chance to experience just one parabola's worth of lunar gravity. And it surprised me because I had always thought that walking on the moon would be like walking on a trampoline. Well, it turns out that Martian gravity, which is 38% of Earth's, that feels like walking on a trampoline because they gave us one of those too. Walking on the moon is like you're almost weightless. It's like somebody just has a dimmer switch and they dial in just enough gravity to keep you from floating off the ground. So you can see in the picture that Ed Mitchell is practically on tiptoes, even though he's wearing that very heavy spacesuit. Finally, the bottom picture is something that became more and more important as the missions went on, and that is lunar field geology training, which was carried out by teams of geologists. The guy in the green and blue striped shirt that's pointing at the front there is Lee Silver from Caltech, who, if I'm not mistaken, Kelly, you actually took a class from him when you were at Caltech, and you can attest to what a spectacular teacher he was. And he was one of the scientists who did really inspire the astronauts to want to do the best job they possibly could on the moon. So, I'm skipping over some stuff here. Obviously, I'm skipping over the launch on the monster rocket called the Saturn V, which was an experience all in itself. But the thing that really sets the Apollo missions apart from anything else that happened before or since is the fact that the astronauts were literally leaving the home planet and looking back as the Earth dwindled in the blackness of space. So this is a montage that I put together of images from the Apollo 8 mission, the first flight to the moon, around the moon. And you can see the amazing view of the Earth that they had. I mean, these guys were not looking at the Earth the way people who orbit the Earth at close range see it. That's a horizon to horizon panorama. This is, you're looking at a planet, and that was obvious and amazing to all of them. And the beauty of the Earth is something that they all talk about, and the sensation of watching it get smaller and smaller and smaller. Although I will say that I had a lot of conversations where I was trying to elicit awe, and it didn't always work. I remember Apollo 17 command module pilot Ron Evans. I spent quite a long time talking to him on a few different sessions. And at one point, he and I were taking a walk around his neighborhood, and I said, but Ron, what about seeing the Earth shrink to the size of your thumb? And he thought for a second, and he said, well, but it was supposed to get small. And that pretty much sums up what I was up against with a lot of these guys, that, yeah, it was an extraordinary experience, but it was something that was exactly what they had trained to expect. So after a trip of just under 3 days, they arrived in orbit around the moon using the big engine on the mothership to go into an orbit that they eventually circularized at 69 statute miles, or 60 nautical miles. And at that altitude, you get an idea in these pictures what they saw. In fact, I really like the one at the left because you can see the reflection of the astronaut's hand as he holds the camera up to the window. I mean, this really is a tourist shot over the lava plains of the lunar near side. I'm pretty sure this is in the Aristarchus, the general region of the Aristarchus Plateau. And on the right, you see a view over the lunar far side, and in particular, the dark-floored crater of Tsiolkovsky, which is really one of the only mare deposits on the far side of any consequence. It's a very different aspect once you go around the far side of the moon. And they, of course, had trained long and hard to recognize these features, and they knew what the scientists wanted to understand about them, and that helped them be better observers and report what they saw back to Earth. One of the things that surprised me when I talked to the guys, it shouldn't have surprised me, but it was still amazing to hear, was they commented that as you go around the moon, you can definitely tell how much smaller it is than the Earth. You feel like you're kind of looking over the edge of it around the curve of it. And it's a very different sensation than going around the Earth. And of course, in lunar orbit, the most wondrous experience, I would say, that's not an overstatement, was coming around from the far side and seeing the Earth rising beyond the moon's horizon. So, Bill Anders was on Apollo 8, the first guys to see that. And, he said when he saw the Earth coming up, and don't forget, it's 4 times the size of the moon, but that still only makes it 2 degrees wide. So, you can cover it with an outstretched thumb if you want to. And the thing that went through his mind was kind of 2 thoughts at once. One was how beautiful it was, especially in contrast to the kind of bleached appearance of the lunar far side, because when they came around, they were pretty much in high sun angle, almost noontime illumination, and the surface was very bleached looking and barren, obviously. And the contrast of that with this beautiful Earth, the deep blue of the oceans, the white clouds, and wherever they could see land masses, the kind of browns, or in case of Australia, a vivid kind of reddish brown. So that was one part of the double thought that came to him. The other part was how small it looked. And he said to himself, geez, I hope we hit that thing. Meaning, when it's time to go home, we're going to have to thread the needle getting into that atmosphere safely, just a couple of degrees margin as you come in. And hopefully you even get that close. Nobody had ever done this before. So even though he knew everybody had figured it out, when you're actually having the experience, that's what goes through your mind. So landing on the moon was by far the most challenging part of any Apollo mission. Neil Armstrong obviously was the first guy to do that, to fly the lunar module down to the surface. He and Buzz had, some real almost showstoppers on that landing, the computer alarms that threatened to abort the landing, the fact that the computer had targeted them for a crater the size of a football field that was ringed with car-sized boulders. He had to fly beyond that and look for a safe place. And then as they got down the last, few tens of feet, from about 100 feet or so on down, there was a new problem that nobody had really anticipated correctly. And that was the effect of the rocket engine on the lunar module as it kicked up lunar dust. And, this is something that no human eyes had ever seen before. What I'm showing you here is a still from an animation that was done by the special effects wizard, John Knoll, who now is one of the chief guys at Industrial Light and Magic, but he's also a huge Apollo fan. And he did a wonderful animation of the Apollo 11 landing. And here you see the last few feet of the descent, and you can see that the dust is going out radially in kind of streaks. And these streaks were moving and making it very hard for Neil to judge his lateral speed over the ground. And he ended up picking rocks that were kind of protruding up above the dust and using them as signposts to be his reference as he guided the lander down the last few feet. Meanwhile, very aware that his fuel supply was getting lower and lower and lower. And he landed with, somewhere between 20 and 40 seconds of fuel left before they would have had to abort. In fact, he told me that in the back of his mind, he was thinking, well, if the engine quits, we're probably okay. We'll just fall onto the moon. That was not in the front of his mind. That was in the back of his mind. Still a very cool thought. And then once they were down on the surface and the engine, and he shut the engine down, he then looked out the window and saw these dust particles just sailing out to the horizon. Each dust particle was traveling on its own long ballistic arc. And then, these dust particles raced out to the horizon, which was a mile and a half away, and then utter stillness. And he just said it was one of the most incredible things, well, obviously, that he'd ever seen or anybody else. Getting out of the lunar module onto the surface, this is one of my favorite shots from Apollo 14, and it does show what a strange experience it was, because you've got a brilliant sun, right? No atmosphere to attenuate the sunlight, so it's a very intense light source, and that's why they needed not only the gold reflecting visors, but they needed opaque sunshades. But yet it's in this black sky. And that's something that human beings have never seen before either, while standing on the surface of some place. I mean, they'd seen it in Earth orbit, they'd seen it on the way to the moon, but now you're in a landscape that has that quality. Notice also the brightness of the moon. I mean, in this picture, everything's dependent on the exposure that the camera was set at, but it is a bright surface. It is not the way you often see it depicted in movies, even in a particular miniseries that I won't mention. I was after them not to make it too dark. They didn't always listen to me. And so, and then you have the vivid, in contrast to the kind of grayish tan color of the moon, you have the vivid colorations of the lunar module with its insulating foil and the US flag. Of course, the other thing about the surface that they noticed right away was this pervasive layer of very, very fine-grained dust. Of course, it makes perfect sense if you think about the fact that there's no atmosphere to prevent micrometeorites from just slamming into the surface for billions and billions of years, grinding the rocks into powder. And so that powder is all over the moon. And you can see here that Buzz on Apollo 11 has made a footprint and is now holding his foot above that footprint as a kind of a reference to give the scientists back on Earth an idea of how the soil behaves. And you can see that those very, very fine grains record the imprint of his boot very crisply. You can also see that those fine grains stick to his boot pretty ferociously. And just about everything that they handled, every piece of equipment got really dirty, including their suits. This is a shot from Apollo 12, the second landing. And it's really unusual because it's one of the only still photos that shows an astronaut running on the moon. And this is Alan Bean. And Pete Conrad, who took these pictures, was not trying to get a photo of Alan running. He was taking a panorama of a crater that they had stopped at to collect samples. In the rightmost frame in the distance, you can see the lunar module, the top half of the lunar module kind of sticking up above the horizon. So you get an idea of how far away they were. They're still within walking distance, of course, but much farther than they had gone on Apollo 11. When I see this picture, oh, and you can also see that in the 1/6 gravity of the moon, you know, even though Alan weighs 180 pounds probably, and his suit and backpack weigh another 180 pounds, so Earth weight of 360 pounds, but on the moon, that's only 60 pounds. And Alan told me how amazing it was to run on the moon, because you each time you stepped off, you'd kind of go into space like you were on a ballistic arc, which, you know, of course he was. And it was actually long enough, he said it was long enough for the muscles in his legs to relax before he hit the ground again. And he said it was like he would never get tired. Now, on these early missions where they were on foot, that was a bit of a challenge in terms of navigating. So this is a picture that was taken on Apollo 14 when Al Shepard and Ed Mitchell, on their second moonwalk, hiked up the side of a big hill that had a crater at its summit, and they called it Cone Crater. And the hope was that they would get to the edge of the crater, which was, you know, roughly football field size, and you know, they would be able to look into the crater and see the geology and have this amazing view. Well, it was quite tiring to walk up the slope in the pressurized suits. Ed Mitchell said that it was kind of like being on sand dunes in the middle of the Sahara, but they were kind of rocky ridges that kind of went up and down and up and down. And every time they came to the top of a ridge, they thought they were at the rim or near the rim, and it turned out that they weren't. Well, this is a panorama that Al Shepard took after they had decided to give up looking for the rim of the crater. What they didn't know was that the rim of the crater is just beyond the sort of ridge that you see at the right side of the panorama. There's some light colored boulders over there that they ended up walking over to. And at that point, they were only, about 70 feet away from the rim of Cone Crater, and they just didn't know it. Because it's so hard to recognize things from, you know, relatively low resolution orbital images, which was all they had with them. You know, when you're walking on this surface, the craters are all foreshortened and so forth. So that's why it was such an improvement when they, on the last 3 missions, gave the astronauts the lunar rover. And now here you see the lunar rover in action. And you see John Young driving it across the Descartes highlands on Apollo 16. And you notice that the front right wheel is completely off the ground. Again, the moon's 1/6 gravity, it's almost like floating. You also see, I often cite this. This is a still from a movie clip that Charlie Duke shot as part of an engineering test objective to record, to document how the rover behaved in 1/6G. I often cite that bit of movie film, which is available on YouTube in high def, as a great kind of rebuttal to the people who think that the moon program was a hoax. Because if you watch the movie, you see the behavior of dust in a vacuum in 1/6G. And that's not something that we knew how to fake in 1972 when this mission took place, never mind a lot more recently. Maybe we can do it now, I don't know. But it's a pretty cool image anyway. But the rover was a real quantum leap for the astronauts, because now they could go for miles, literally miles, and go to some of the really interesting places that the scientists wanted them to visit. And of course, they had a fairly rudimentary navigation system. And of course, the places that they landed, there were mountains to use as references also. Now, here's a great shot from Apollo 15, and Dave Scott, the mission commander, is getting some gear off the rover. And in the background, you see why these later missions were so spectacular. That peak, rounded peak that you see is called Mount Hadley Delta. It's 11,000 feet high. So we're talking about, Rocky Mountains scale of images, of features. And he and Jim Irwin actually drove a few hundred feet up the side of that mountain. I'll talk more about that in a minute. Now at the right, you see that they are at the edge of a giant canyon called Hadley Rill. And that was the other great lure of this mission, was to be able to go to the edge of this canyon where you have lava flows that have cooled into layers of basalt, and you can kind of page through the lunar history book one layer at a time. They didn't have a lot of time to do that, but they did manage to get a number of really great samples from the edge of that rill. Now here we are, the previous day. This is the second EVA, the second moonwalk on Apollo 15, and here's Dave Scott photographing a rock that he is about to sample. This sort of spidery looking gizmo just right of center is called the gnomon, and it was used to as a reference in the pre-sampling collection photo of any given rock, because it had a staff that would show the local vertical. It was a known size, so you could compare the rock with that, and it had a color chart on it. But what you see here is a panorama that Jim Irwin took up on the side of that mountain that I just showed you, Hadley Delta. And they're hundreds of feet up above the side of the floor of the valley. This beautiful, brilliant plain, a cratered plain, undulating plain, and beyond it, more of the lunar Apennine Mountains, beautiful rounded forms under that black sky. And I think you should be able to see also how dirty Dave's suit is by this point, after, almost 2 days of exploration. Again, that very fine dust stuck to everything, but also notice the steepness of the slope. It was really very tiring to go upslope, especially because of the thick dust. They said it was like walking up a sand dune. But, this is the place right around here anyways, general area, where Dave Scott and Jim Irwin found for the first time on any Apollo mission a piece of the moon's primordial crust. And, it was a type of rock called anorthosite that's made up of a particular variety of feldspar, calcium feldspar. And it had been predicted that they might find that in this location. They were kind of ready to recognize it if it popped up, and sure enough, it did. So that was a spectacular moment in this mission. And as I say, the astronauts had been trained by Lee Silver and others, and had been, they'd kind of caught the fire, they'd caught the spark of excitement about being able to solve some scientific mysteries. And so they were genuinely excited. You can hear it in the recordings, the video, if you look that up, how excited they were when they found each new sample. Now, this is a very cool composite that I put together. The main image on the left is a picture that Jim Irwin took with an 80 millimeter lens and the Hasselblad camera. So it's sort of a normal eye view from the side of this mountain. In fact, you can see the rover tracks at the bottom right snaking down the slope that they had driven up, and beyond that bright undulating plain. Notice the white box though at the left. That is the area covered by the image at the right, an inset, which Dave took with a 500 millimeter lens. That lens was good enough to show the lunar module sitting on the plain, and it was about 3.5 miles away at this point. So, if the rover broke down, they would have a long walk back to their only safety. And yet, when I talked to Dave about it, he said, man, I was not worried at all. Everything was working so great. And we were just so excited to be there and to be doing this exploration that we've been so primed to do. So and in fact, Dave told me that this pair of pictures is his favorite picture, or comprise his favorite picture from the mission. Apollo 16, the next rover mission, was an interesting story to write about, because the scientists thought that that landing site, the Descartes Highlands, would turn out to be composed of volcanic rocks, basically two different types of lava flows in the lunar highlands, the central highlands near the crater Descartes, or bigger crater that you can see really easily from Earth is Albategnius. It's that general region, and they thought, oh, this is going to be so cool. These guys, we're going to send these guys, John Young and Charlie Duke, to the Descartes Highlands, and they're going to land on what we call the Cayley Plains, and that's going to be, one type of lava, and then they're going to go up onto the mountains, which are called the Descartes Mountains, and that's going to be a different kind of lava, more viscous lava. Well, John and Charlie got there, and they did not see volcanic rocks. What they saw, what they found and collected, were breccias. That's a word that refers to a rock that is composed of fragments of pre-existing rocks that were broken up and welded together in the enormous heat and pressure of an asteroid impact. And here you see John and Charlie. This is a mosaic that I made from frames from the rover's TV camera. And John and Charlie are standing at the rim of an enormous crater called North Ray Crater. And, they just kept finding more and more examples of these impact created rocks, and absolutely no volcanic rocks at all, other than a kind of a rock called an impact melt, which is, yes, created from a molten state, but it's really material that's been melted by the impact process, and then rained back down to form a coating on other rocks. So yeah, they found impact melt, but they did not find any lavas, any lava rocks. Now, while they were at North Ray Crater, they visited a very large boulder off to the right there, that dark boulder, which turned out to be the size of a house. And one of the things they'd been told was the bigger the rock, the less distance it traveled because of the impact. So that is ejecta from the crater. It was blasted out of the lunar crust by the impact that created North Ray. And the fact that it's so big must mean that it came from the crater floor. That's basically how they told the astronauts to think. So, okay, here we go. We're going to get a sample from, quite a ways down, dozens of yards down into the lunar crust. And that turned out to be a big breccia also. So, the guys on the ground, the geologists on the ground, never doubted Young and Duke for a minute. They knew they were great students. They had become very good lunar field geologists. And, the Capcom, Tony England, who was a scientist astronaut, was kind of worried that maybe they would be doubting themselves. And he tried to kind of subtly reassure them in his talk to them, over the radio. They weren't worried at all. They just felt like, what? Our job is not to find what they told us we would find. Our job is to find what's here. And that's what they did. This is also from Apollo 16, and it shows John Young cinching up a bag of lunar dust. And I show this just to give you an idea of the physical exertion that the astronauts had to deal with, particularly manipulating the gloves of the suit. The entire suit was pressurized at about 3 pounds per square inch or so. But it's like being inside a Michelin tire. And, every movement of the suit was work, and in particularly moving the fingers of the gloves and gripping any kind of object, because the glove is molded out of latex rubber and reinforced with all kinds of stuff, but the mold is made with the astronaut's hand partly open and not completely open, not completely closed. So closing your fingers around something like a sample bag or a collection tool or a camera, you are squeezing against that pressure all the time, and it really wears out your forearms. And another problem that they had was that the ends of their fingers were kind of ramming into the fingertips of the gloves, and some of the guys had broken blood vessels under their fingernails, which was quite painful. And John Young, you see the title of the slide. John Young said to me, you've got to learn how to work your hands when your hands don't want to work anymore. And everything I'm telling you is a lesson for the Artemis astronauts who are going to try and go back to the moon. They're going to have to deal with these exact same things. They're going to have to deal with the dust. They're going to have to deal with the slopes. They're going to have to deal with working under a timeline. All these things that the Apollo guys were up against, the Artemis astronauts are going to have to do too. And of course, they're going to have to be highly motivated to be good lunar field geologists. So I'm actually doing a little work with some of the scientists at NASA to share these stories in hopes of helping that improve the training program. There are a lot of people who are involved in that, and some really good folks, and they're very aware of what they have to remember from Apollo, but I'm just going to try and add to that. I just mentioned the dust and how it sticks to everything. Look at this is Apollo 17. Look at Gene Cernan's suit. I mean, the arm of his suit is just completely coated in grime. John Young said to me, when people go back to the moon, the thing they better worry about is the dust. And and one of the reasons the dust is such a problem is because it's angular, right? It's impact particles, so it grinds away at whatever it touches. Here's Gene inside the lunar module after the last EVA, tired but happy. And he told me, you get to the point where you got to go to sleep according to the flight plan, but man, who wants to sleep on the moon? That's the last thing you really want to do. It's such an incredible thing to be there. But anyway, this is kind of a human moment. Now, let me talk for a minute about the guys who stayed in lunar orbit, the command module pilots, while the commander and the lunar module pilot were on the surface. So this is an Apollo 16 photo. At the left, you see the mothership, Casper, with Ken Mattingly inside. This is a picture that was taken by Charlie Duke from the lander as they were sort of station keeping in orbit. And, I talked to Ken Mattingly, who was just a fabulous interview, very, very soft-spoken, quiet guy. But man, he was just such a great interview. It was the last one of the project too. I had to wait the longest to talk to him. And he said, I've never done it, so I can't be sure about this. But personally, I just cannot imagine how bouncing around on the surface of the moon would be as much fun as flying a spaceship alone over the far side of the moon. You're looking out the window at this, fantastic dreamlike, he didn't say dreamlike, but amazing landscape, dead quiet. He actually brought tapes of, classical music, Mendelssohn, with him to listen to. He just had a ball. And all the guys that orbited the moon alone said it was a really special experience. This is a mosaic of pictures that I put together that Ken took from lunar orbit of a far side crater called King crater, with a rather unusual forked central mountain complex. Just to give you an idea of what an incredible amount of detail you can see from that 69 statute mile altitude. And of course, there were other cameras in the side of the mothership that were taking much higher resolution pictures. But Ken was also, like all the command module pilots, was very busy observing all the details and reporting them back, to try and help the scientists answer the questions that they wanted to. Finally, this is a picture from Apollo 17, taken over the far side, but in the part of the orbit where there was no sun in the sky, lunar night, and so utter blackness. And this is obviously a time exposure, and you see a bit of the zodiacal light and or the solar corona there. And at the lower left, the horizon of the moon as a silhouette. And, that experience of being alone in the command ship, looking out at all these stars, you see so many stars in that situation. A couple of them said it was, more stars than they'd ever seen on the clearest night on Earth. And Al Worden in particular on Apollo 15 described it as almost a kind of a communion with the universe. And he said, you look out at all those stars and you realize that if there's any life out there at all, then the universe just has to be teeming with it because there are just so many stars. And Al Worden actually came back from that flight and wrote poetry, which you would not expect a test pilot, Cold Warrior test pilot to do. But that's what I referred to earlier as the interesting differences among these guys. Now, the guys down on the surface obviously had to get off the surface to rejoin the mothership. And so the moment of truth was when they, told the computer to fire the ascent engine and get off the surface. And that is the moment that you see here on Apollo 14, captured by the onboard movie camera. And you can see bits of Kapton foil blowing away from the blast of the engine and the flag flapping in that blast as well. And thankfully, of course, it worked every time. That is a testament to the quality of the work that everybody on Apollo did, just about everybody on Apollo. And that's kind of what I do these days is I teach at NASA and I've taught elsewhere about the elements of success and failure in terms of human behavior, the mindset that you have to succeed in something like sending humans to the moon for the first time. And this is the moment of reunion when the surface guys came up and were about to dock with the mothership. This is from Apollo 17. You could see Gene Cernan in the window of the lunar module ascent stage just before he rotates into position for the docking. And then leaving the moon, obviously, was another moment of truth. The mothership's big 20,000-pound thrust engine. And, that was a nail biter for the guys, but worked every time. And then when you look back at the moon, you can literally see it getting smaller as you watch. That's how fast you're going as you leave the moon. And that was just a really memorable experience. This is a frame from the high-powered cameras that I mentioned in the side of the mothership, the so-called mapping camera in this case, from Apollo 16. So you're seeing mostly the far side with a little bit of the near side at the upper right. And then on the way home, on the last three missions, the rover missions, that film from those high-powered cameras had to be retrieved, and that was the command module pilot's moment to shine and do a spacewalk. Now, this is a spacewalk that is right out of science fiction. It's really a 2001 kind of a moment because you're a little more than halfway between the moon and the Earth. So the moon is a little ball off in one direction and the Earth is a crescent off in another direction and the sun is somewhere else. and everywhere else is this utter blackness. And Ken Mattingly did it on Apollo 16 and said it was just one of these things that made his heart pound as he looked over the side of the module into, this abyss. What you see here is Ron Evans from Apollo 17 in the process of collecting those film cassettes. And now back on Earth, 15 was the first mission that didn't require the astronauts to go through quarantine. So, they had the luxury of sitting in the life raft and breathing the wonderful smell of the ocean and the fresh air after being cooped up in various spacecraft for 10 or 12, 10 days, 10, 11 days. And, and that was an incredible end to an incredible adventure. And finally, let me go to the last slide here. I want to just take a moment to recognize the guys who did not stand in the spotlight nearly as much, but without whom this would never have happened, some of the giants of Apollo. So on the left, you see, this is a picture taken at the celebration of the safe return of the Apollo 8 astronauts. The far left with the light-colored jacket is Bob Gilruth, who was the director of the Space Center in Houston, and really created a lot of the success culture of human spaceflight. The guy in the middle in the dark jacket and the striped tie is Chris Kraft, the architect of mission control. Next to him on the right is George Lowe, one of my heroes. He led the recovery from the fire in '67 and went on to really guide the Apollo spacecraft program to the first lunar landing. And then in back behind Chris Kraft with the glasses is General Sam Phillips, who brought a lot of the techniques that I talk about these days, the systems engineering and the systems thinking, systems management to Apollo, without which NASA would not have succeeded. So with that, I'm a little over my time, but hopefully not a problem. And I'm happy to have your questions.
Not a problem at all. Thank you so much, Andrew. We've lost sight of you for some reason. There you are. Hey, I have a couple of quick questions if I can jump in.
Yeah.
So I wrote them down as we went along. I thought it interesting you mentioned how in the back of Neil's mind about running out of fuel, or I've always wondered about those alarms. Do you think he would have landed it irregardless? I mean, when you're literally, you could almost reach out and touch the surface.
Well, no, when the alarms came on, they were actually quite high up. In fact,
okay.
The first batch of alarms happened before pitch over. And the second batch, I think, there was 2 or 3 occurrences of them, and they kind of went from, a minute or 2 before pitch over through the early part of the final descent. So no, they were not in a position to go ahead and land without the ground telling them that it was okay. In fact, they did not get out from under those alarms until they were about 1,000 feet above the moon.
Okay.
And it was at that point that Neil looked out the window and saw that the computer was aiming for the, football field sized crater. So yeah, no, that was, and it's a really interesting thing. If you dig into the cause of those alarms, it turns out to be an effect that had to do with the phase of the voltage in the power supply to the computer versus the phase of the voltage for the lander. And once in a great while, when you powered up the LEM and then you turned on the computer, if the phase was in just the right relative configuration, you'd get those alarms. And it was one of these things that should have been handled by what's called an interface control document, because it was sort of known, but it just didn't get communicated enough to work around it and prevent it. Now, the other thing I'll add to that story is the real hero of that was Gene Kranz, the flight director, because they had a simulation a couple of weeks before the flight with one of the backup crew, actually the Apollo 12 backup crew, Dave Scott and his guys. And those alarms came up, and mission control, Kranz's guys did not know what to do. And they ended up aborting the landing, and the instructors, who were always trying to get the better of the mission controllers, said, you guys should have known how to handle that. And Kranz turned to his computer guy, Steve Bales, and his other guy, Jack Garman, said, I want you guys to be ready for any computer alarm. And Jack Garman was the guy who had the little cheat sheet.
Mm-hmm.
So they knew what to do.
That's pretty cool.
Yeah.
The picture you showed that raised goosebumps. And I always marveled at how far away from the lunar module some of those guys actually traveled. That must have been they must have been able to see it.
Well, you know, when I showed, I did a book called Voices from the Moon, which I happen to have here. Oh, you can't see it because of the, there, you can kind of see it.
There it is a little bit, yep.
Yeah, so in that book, I have that same spread. And I gave a copy to Dave Scott at a astronaut gathering that I was at. And we were sitting there looking at it. And I said, you know, Dave, I got to tell you, when I look at the wide angle picture, not your 500 millimeter one, but the one Jim took, I can't see the LEM in that shot. I'm amazed you could even see it from where you were standing. And he said, oh yeah, you could see it because of the glint.
Sure.
And what he was talking about was this, again, this intense sunlight of space on that Kapton foil. Even from 3.5 miles away, it was vivid. And that's one of those great moments where I felt like, okay, you just put me on the moon with you and I've got chills.
Yeah.
So I had that was the great experience of interviewing these guys, was to have that.
That's awesome.
One of the great experiences.
The idea of the quarantine, when I was a kid and watching it, I was like, oh, that's really a good idea. But it always, as you get older, the idea of the quarantine, it was like almost like public relations. Once you pop open that hatch in the ocean.
Yeah. Did you watch the CNN show the other night?
No.
CNN documentary about the quarantine on Apollo 11. And my wife and I were sitting there. I said, hatch is open, germs are getting out. You know, if there are germs, this is pointless. It was mostly a political consideration.
Sure.
I think there were countries, particularly foreign countries, who just were, would not have been okay without that happening.
I only have two more quick questions. Well, one of them goes right back to what we were just talking about. Didn't the astronauts say that the lunar dust had an interesting odor to it?
Yeah. Buzz said it was like gunpowder.
Mm-hmm.
And Jack agreed with that, Jack Schmidt, and said that it has to do with the oxygen in the cabin interacting with the lunar soil,
sure,
which has obviously not been exposed to oxygen before.
Right. Fantastic. That picture of the lunar module you showed us, it was I assume approaching back to rendezvous with the command module. Right. The skin looks wrinkly on it, not the foil.
Yeah. Right. The skin.
How thick was that skin?
Very thin.
That's crazy.
Everything about the lunar module was to save weight without sacrificing capability. So you had spars made out of whatever it was, aluminum, I guess, that were structural members. And then the skin was just basically tacked onto that.
Yeah.
But within that structure was the crew cabin.
Sure.
Which was also very thin.
That's pretty crazy.
That was a separate piece within that outer shell and skin.
Wow. And one last thing, I seem to remember reading in your books, the 3-volume set, didn't Conrad and Bean on Apollo 12 try to take a selfie of themselves?
Yeah. And in fact, if you go on the Apollo Lunar Surface Journal and you go to the Apollo 12, well, let's see, I'm not sure. There's a page that he just calls fun. And I mocked that up once. I mocked up that life cover. Pete had gone to the trouble of getting a little timer, little gizmo that you could stick on the Hasselblad camera and push it, and it would delay the shutter firing for 10 seconds or whatever. He'd have time to run over next to Alan. And when they got to the Surveyor, he had put it in the rock collection bag on their tool carrier and couldn't find it. It was obviously covered with lunar dust by that time, and it didn't get found until they were back at the LEM dumping the samples into the rock box, and it fell out, and he threw it into the distance as hard as he could.
Well, those are the questions I had. I don't want to, I could talk to
Yeah.
you all night about this, but
No, it's
let me
cool.
let
As
me
long
let
as
other
people wanna- as long as
people
wanna ask
unmute.
questions.
Go ahead, everybody, ask away.
I'm going to jump in. Thanks, Rich, and thank you, Andy. Great to see you.
Yeah, you too.
You mentioned obliquely the Artemis program, and I'm wondering if you have any designs on following.
Yes.
Well, no. I'm following them in much the same way that you did the Apollo astronauts, and in particular, the notion that Apollo was one of the greatest, if not the greatest, technical challenge that humankind has ever accomplished. And for Artemis, it's kind of, I don't know, it's almost got this sort of quasi-commercial tinge to it. How do you compare the two in terms of the astronauts' preparedness and their mindset?
Well, I haven't talked to many of them for very long. I know some of them. And I hope to get to know them. I hope to be able to talk to them before and after, obviously. But, they're very gung-ho people. I mean, as you can tell from watching them on the space station and seeing how they express that experience and how comfortable they are talking about their experiences and about, much more so than the Apollo guys, obviously a different generation. As far as the mode of doing Artemis versus Apollo, opening up the competition for the lunar lander to commercial companies and so forth, I'm sort of doing a wait and see on that. I really am going to be interested to see what they come up with. I am a little worried about the lack of more flights being programmed in to do the level of testing that they did on Apollo. I'm in that sense, I'm really feeling like I'm in wait and see mode. But in terms of the motivation of the people, the science folks who are training the crews themselves, I have a very good feeling about all of that. It's the comparison with Apollo in terms of testing and validating everything is going to work, because I'm so aware now, as a result of this work that I've been doing for 10 years on success and failure. I'm so aware of how easy it is to talk yourself into a mindset that, well, we've really covered all the bases and we're good, when in fact something can just be around the corner to bite you. The best intentioned teams are vulnerable to that. I hope that answers your question. All right.
John Harrington had a question. John, are you there? Well, John typed in chat. He was asking if any of the instrumentation left on the surface of the moon by the Apollo guys are still functioning.
No. And that's a bit of a sore spot for a lot of folks, because they were turned off in 1977, and they were still functioning at that point, but they were turned off in 1977 to save money. So, that's a shame, but that's how it went down.
What about the retro reflectors?
The retro reflectors, which are passive, yeah, they still work. they still work. I mean, obviously there's probably a coating of dust on them now. And I don't actually know what that's done to the performance of the reflectors, but I'm pretty sure that they still work and that they've been used. Just unmute and holler away.
Yeah,
Mark.
Mark, you have a question? There you go.
Yeah, I'm curious. You were talking about the success and failure. I had the pleasure of meeting Fred Hayes maybe 5 or 6 years ago. And, you know, I asked him about what it was like to go, you know, get all the way to the moon and then find out that you know, had to turn around and come right home. But did you get to talk to any of the Apollo 13 astronauts? And
Oh, yeah. I mean, they count. They
yeah,
definitely.
because like you said, with the success and failure part of it.
Oh, no, but I mean, I talked to them at great length for a man on the moon. The only one of the 24 lunar astronauts I did not get to was Jack Swigert, who'd passed away in 1982. So, you know, yeah, I spent hours with Fredo and have talked to him since. In fact, I had a conversation with him a few months ago about the success and failure stuff, and he's right on board with that stuff. He's very mindful of all of that. And all the guys are. You know, Apollo 13, if you want to put it in a nutshell, why did Apollo 13 happen? It happened because one contractor, Beech Aircraft, who made the oxygen tanks, didn't bother to tell their subcontractor, who made the little thermostat inside the oxygen tanks, that they were going to need to operate at a different voltage than they originally thought, because the voltage used for ground test was changed around 1965 to a higher voltage. Nobody told the thermostat guys that. So when they had a problem with the tank in Apollo 13, they couldn't detank it after a test countdown the normal way, and they had to boil off the oxygen to detank it using the heaters inside. The thermostat was supposed to control that, how long the heaters are on. But as soon as it saw power, it fried. And so the heaters were on for hours, and they fried the insulation on the little fans that stirred the contents so that they weren't stratified and the guys in mission control could get accurate readings. So, you know, there's a causality chain, but basically it comes down to that one piece of miscommunication.
Sometimes it's the littlest things that make the biggest differences.
But I really, I mean, for the purposes of this discussion, you'll find it interesting. When I talked to Jim Lovell, he said, you know, if I had it to do all over again and I could choose, he said, I'd want to land on the moon because that was my goal. But my second choice would still be to do Apollo 13 as it happened, because that was such a great demonstration of capabilities for a test pilot. And Fredo didn't feel that way at all. He just said it was a huge disappointment, and it still was. He gets a better feeling from the work that he did on the space shuttle, from the design and development phase through the first approach and landing tests with the Enterprise at Edwards. So interesting stuff.
Thank
When
you.
I was able to see these guys through the lens of professionalism, a lot of things kind of clicked into place. Raise your hand. Oh, I can't see all of you at once. So
Yeah, just
maybe-
unmute and have at it.
Yeah.
Or I'll keep asking questions. Steve Cloudy has his hand up. Go ahead, Steve.
Hi, Andrew.
Yes, Steve.
Yeah, I've got one of your older books, and it was a fascinating read. And I don't know if it was there or somewhere else where I saw this reference just prior to Apollo 11's flight in 1969, which happened 1 month after I graduated high school and registered for the draft,
Oh boy, that's some
I
month.
might add. It was told, I had read that, yeah, that the crew got to meet Who flew the Spirit of St. Louis across the Atlantic in
Charles Lindbergh.
1927?
Charles
Yes,
Lindbergh,
Charles
yeah.
Lindbergh.
Yeah.
And they met, and they did a back of the envelope calculation and
Yeah.
decided that the first 1 second of the Apollo 11 flight consumed as much fuel as the entire flight across the Atlantic Ocean in 1927. Did you hear any? Okay.
That was the Apollo 8 crew having
Oh,
lunch.
Apollo 8. Okay.
But Neil and his guys would have been at that as the backup crew. I think they were there too. The backup crew for Apollo 8 was Neil's crew.
That would be Frank Borman, Apollo
Right.
8.
So Frank
Yeah.
Borman, Jim Lovell, and Bill Anders. And in fact, yeah, I mean, that was just a thrill for them because Lindbergh to them was like the astronauts were to us.
Sure.
Yeah.
Yeah.
That's a true story.
Okay, it is. Okay. Thanks for verifying that.
And Anne Morrow Lindbergh's book Earthshine tells some of that story. Mike Collins' book Carrying the Fire, I think, has that story, and Jim Lovell's book certainly does. And of course, Lindbergh wrote the foreword to Mike Collins' book.
Mm-hmm.
So you might want to look at some of those.
Oh, I don't know. Do you have any idea how long he lived? Lindbergh?
Lindbergh died in 73 or 74.
Oh, so you had met him at that point, prior to that point. Okay.
They met him in 68.
Mm-hmm. Yep.
Andrew, my own personal memory of Apollo, we lived in Worcester, Mass, just 40 miles west of Boston. Worcester. And I really did. I wrote in the newsletter that I had asked my parents if we could move to Florida so we could be closer to the action because I was super into it. And they just gave me that look like, you forget it, kid. But so I mean, I was deep into this stuff. And I used to set up a tape recorder on a little teeny TV upstairs so I could record the audio of everything that I could possibly record. But on the night Apollo 13 left Earth orbit and headed off to the moon, it was, again, living in New England, you couldn't see most of the stuff. The Mercury missions, the Gemini, were just too far north. And those guys never came above the horizon, at least, or we wouldn't have even known when to look for them.
Yeah.
But the night, I think it was April 11th, 1970, right? I went outside with my telescope. I had an 8-inch reflector in the day, and I happened to look up at the sky, and I knew the sky pretty well even then. And I noticed a little fuzzy star in the sky, and it wasn't supposed to be there. So I trained the telescope on it, and it was the Apollo spacecraft heading to the moon.
That's amazing.
The fuzziness was probably a liquid oxygen dump. But the reason I immediately knew when I looked through the eyepiece was because I knew the whole timeline of the mission and how they, undocked in the third stage, turned around, released the doors, and went in and got the lemon, pulled it out. Well, I could see one or two of those doors as little points of light, catching the sunlight and, flashing. I could actually see them in the telescope.
Have you ever written that up? That would be a good letter to Sky and Telescope or someplace, space.com. Yeah, you should get that down.
It was pretty cool. I mean, I had enough time to get the family out to look at it, and even some of the closer neighbors came over and looked at it through the telescope.
Did you see it move relative to the other stars?
You could actually see it moving. Yeah.
Wow, that's amazing.
Cool. It was cool.
You need to write that up.
All right, I'll have to dig out my notes and put something down. But no, that's a true story.
Yeah, and take little pictures of the notes and put it in the web post.
There you go.
I'm not too bossy.
It was a lot of fun. It was fun. It was really cool. I remember looking at the moon as Apollo 16 was landing, and in the hopes of, looking through this with the same telescope.
Yeah.
In the hopes of maybe, I thought if they were kicking up dust, maybe I would see a little brightening of a little teeny speck of surface on the moon. But now, in hindsight, of course, it's impossible.
Right.
When you go in on the lunar reconnaissance orbiter, images, and you see
they crashed a Centaur into the lunar South Pole, and there was really tough to see that.
Right, right.
So
No, I was just a wide-eyed kid, just giving it a shot. Yeah, it was pretty cool. Like I said, you can explore those sites with the lunar reconnaissance orbiter imagery. And if you know the latitude and longitude, you can go on your
Yeah.
computer and zoom right in on those sites, and you can see the equipment they left behind. You can see some of the tracks.
it's
Pretty cool.
fabulous stuff. Yes.
Pretty cool. I especially like to look at, when I'm looking at the moon through my telescope, I always like to look at, I don't know why, but I like the Apollo 17 landing site. Because
Oh,
you can,
what's not to like?
well, really, but you can see the the valley, you can see north and south massive and the sculptured hills in the telescope. And I like to look at that particular feature on the moon and think about it. Oh, I also like to look at Mount Marilyn. I like to look
Right.
at Mount Marilyn. I look at that every time I can. So
Right.
it's fun stuff.
Hey,
Anybody-
Andrew. Yeah,
There you go, Sean.
I got a question real quick. Andrew, I'm just curious if you ever had the chance to interview Deke Slayton before he passed away. Obviously, part of the original seven, such an important person of basically all three programs, Mercury, Gemini, and
Oh,
Apollo.
yeah. No.
And how he, basically, helped put all the crews together and really from the astronaut office kind of ran everything.
I did. I went to Deke's house and sat with him for a couple of hours and talked to him on the phone once or twice, I think. So yeah, that was really neat. The guy who really obviously spent a lot more time with Deke was Michael Cassett, who wrote his biography, his autobiography, and Michael is just the expert on everything that Deke was thinking about crew selection and all of that, and the ins and outs of picking those crews. And but Deke was a great guy. He was a great guy.
Yeah, no, that's great. I'm glad you get to meet him, because I think he passed away, early 90s or something, right?
Right. Exactly.
Yeah.
Anybody else have questions? Dave has a question.
I wondered if there was any long-term impact of stress or on their psychology or physiology that you might have noticed over time was consistent between them, or perhaps different.
Well, there were variations. Physiology, not a lot of lasting impact that I know of, other than the fact that Jim Irwin died of heart failure and had pretty severe heart arrhythmias during the flight. And they think it might have been, well, this is Jack Schmidt's theory, training in the suits without sufficient cooling and drinking Gatorade, which did not replace at that time some of the electrolytes that you lost through sweating, and that weakened his heart. And I never really looked into the incidence of cancer and whether or not it was above the statistical average. Jack Swigert was quite young when he died of cancer. Al Shepard had leukemia. I think there are a couple of others that had cancer. But I'm not sure if that correlates with, the amount of time they spent outside the magnetosphere or not. In terms of psychological impact, there were only two guys that I would say were radically affected by psychologically, and that was Ed Mitchell in particular, who really changed his life to study consciousness, the nature of consciousness, as a result of going to the moon and the experience that he had coming back from the moon, seeing the Earth and having a feeling of an intelligent universe. That was one. The other one was Jim Irwin, who felt that he had experienced the presence of God while he was on the moon, came back and became an ordained Baptist minister. But the other guys, there were a few who said, nah, it didn't change me, and they were kind of proud of that. And then there were quite a few who said it changed my point of view on some things, kind of broadened their perspective, which is certainly understandable. So there are books, there's a NASA book on the biomedical results of Apollo that you might try to look at. That's available online.
Cool. That sounds great. Any other questions? Andrew, you know what I'd like to do right now? I'm going to take the screen back, just close out the meeting. You're welcome to stay as long as I leave the meeting open until people are tired of it. If you've got to run, we understand.
I'm going to sign off, I think, but thank you all.
Well, listen, let's give Andrew a big round of applause. That was fantastic.
Thank you guys.
I'll get in touch with you tomorrow and
Sure.
just to close it out. But thank you so much for your time and expertise. Fabulous to hear from you again. So thank you.
Great.
Thank you very much.
You're very welcome and great fun. I'm really glad I could have the chance.
Awesome.
All right.
Like I said, I could talk to you all night, but I know you got to go. So thank you very much, Andrew.
Everybody.
Take care. Good night.
Bye-bye.
So let me finish. Let me close out the meeting by grabbing my screen back here, or at least the official part of the meeting. Let's see, what do I want to do here? I want to run the slideshow from here. So, well, you can probably see it just as well. I don't even have to go out further, but the next event, we have a quarterly board meeting on March 25th at 8 o'clock. I'll send out an invitation to that. It'll be Zoom. The board has, I don't have too much for the agenda, but membership is welcome to sit in and listen in on the proceedings. The next monthly meeting is Thursday, April 8th, 2021 at 8 o'clock. I'll open the doors at 7:45 like I normally do.